So there's a good article or also an quote out there from Russ Miles where he mentioned especially chaos engineering can help you to improve your socio-technical system. So your system isn't just technology. It is like the people, the processes, the organization behind how you're running, operating your software, which is getting close to what you have mentioned. The people on call, they need to be trained. They need to be in a position that they can really understand how the system behaves. The socio-technical system really describes what the potential could be if you're doing chaos engineering in such a system.
Yeah, it's totally that. I think people focus on technology all the time, or the tools, right? I think, and for me, technology is kind of the Venn diagram of culture, processes, and the tools, right? So you can have the tools, but without the right processes and the culture around that, you have nothing basically, right? So I think chaos engineering, is super interesting to look to actually englobe in that what you're talking, like the overall system, right? And it's easy to see how actually humans are probably most critical part of systems, because from a resilience point of view, right? When there's a failure, right? These humans that go typically and fix the problem, try to make the system to adapt to the condition, right? There's a term in resilience engineering called adaptive capacity. It's of your system, right? It's how your system is able to move itself or to adapt to the condition. And the only way to really understand how flexible or kind of malleable is your adaptive capacity is actually to go and inject failures and see what are you really good at. I think that's super important. We often focus on what's wrong, but actually understand what you're really good at and bagging on that is probably the most important thing. But also understand where there is room for improvement, right? And very often, it's just a matter of injecting faults, and it doesn't have to be a technical fault, right? People again think about injecting faults into a system. It's like adding latency, and that's great. But one of the experiments I've loved to do is take the laptop of the lead engineer in the team and see how the team is going to behave, right? And
absolutely,
literally most of the time, everybody freaks out, right? Because they have those.
I was on a very nice session together some years ago with Russ Miles, and he also shared that story. I did a game day in my old days as a consultant, and one of the first exercises for myself was identify like this leader. And as Russ told me, get this person out of the room, enjoy the coffee, and now run the game day without that person, this mastermind with the team. And this can really, hopefully, enable those people to really step out of their comfort zone, to be more responsible, to be more engaged with the system, and of course, to learn a lot of more, because otherwise you're just trusting the single person, which is also, again, a single point of failure in a system.
And it's understanding exactly this hidden complexity, right? People have this knowledge inside their brain, and then sometimes, documentation is not up to date, or there's been some changes, or there's some biases or some context that is inherited from the very early days, but the rest of the team has changed. And then, I think being able to, again, that's another thing from chaos engineering that is really good is make sense of the complexity of the system, right? And systems are complex in many ways, right? Technically, socially, and culturally, and all that kind of stuff, and making sense of that. Like, for example, understand, sometimes there's complexity in the escalation process. Sometimes there's complexity in the way a company might, talk to their customers around, they're experiencing an outage and they forget to communicate, right? And again, that's a problem that can be surfaced as well in those game days.